Hello, this is Robert Davies with the Utah Climate Center. In this episode of Utah Climate Notes, we're continuing our look at why climates change. In particular, we'll be looking a little closer at the phenomenon of climate cycles. Each place on Earth has its own set of normal climatic conditions. So the term climate cycle in the context of this discussion refers to fluctuations in regional climates, deviations from these normal conditions that last from a few years to perhaps a decade or so. Some years are cooler than normal in some places, warmer than normal in others. Some places might be wetter than usual for a year or two or five, while at the same time other places are experiencing drought. The early 1980s here in Utah, for example, were exceptionally wet. Recently, California has experienced several years of drought. And in the 1930s, the American Midwest saw a decade of extra warm, dry conditions, the so-called Dust Bowl. And these are all examples of deviations from so-called normal conditions. Further, these deviations come and go, often somewhat regularly, which is why we call them cycles. And these cycles happen all over the world, at different times and in different places, sometimes highly localized, sometimes affecting an entire hemisphere. Now, last time, we connected these regional climate cycles to the notion of energy redistribution, energy flow within the Earth system. It's worth understanding this in just a bit more detail. Energy flows within the Earth system because energy from the sun enters the system unevenly, with more coming to the tropics and less to the poles, and because it is absorbed unevenly by oceans, continents, and the atmosphere. Specifically, when we do the math, it turns out that the equator warms more than the poles, not surprisingly, and that land surfaces warm more than ocean surfaces. As a result, according to the first law of thermodynamics, the energy flows from warmer locations to cooler locations. And this flow of energy happens through atmospheric circulation over timescales of days to weeks, and through ocean currents over timescales of months to years to centuries. Here's a simplified view of the atmospheric circulation driven by different temperatures. And for our purposes today, it's not important to understand all of these details. I just included them to make the point that there are many details, and the circulation is three-dimensional and complex. In oceans, the situation is equally complex, and this illustration shows heat being carried from the equator to the poles via the Gulf Stream, and the intricacy of the circulation patterns is clearly evident. But that's not all. Further complicating the scene, energy is also exchanged between the oceans and the atmosphere. The El Niño-La Niña cycle, a periodic warming and cooling of surface waters in the tropical Pacific, is a well-known example of such an exchange. When the ocean waters are warm, as shown here, the ocean is dumping energy into the atmosphere, and the result impacts regional climates thousands of miles away, an example being intense precipitation in California. Further, there are many different cycles of energy exchange within the climate system, with names like the Pacific Decadal Oscillation, the Quasi-Decadal Oscillation, the North Atlantic Oscillation, each operating in different places and on different timescales. To get a sense of the level of complexity, imagine sprinklers that come on at night on a golf course. They pop up at various times, sometimes overlapping, sometimes not, and deposit water into the hole on the green. And now imagine you can't see the sprinklers directly, but you can measure how much water is coming into the hole, and when, and with that information you'd like to figure out how many sprinklers there are, how fast they go around, and when they turn on and off. Well, this is the task of climate scientists in identifying different cycles within the climate system. Complicated, yes, but possible. Here at the Utah Climate Center, for instance, researchers have identified three important cycles that impact our state's climate, originating in the Pacific, the Arctic, and the Atlantic. Well, next up, a closer look at longer-term trends. Utah Climate Notes is a collaboration between the Utah Climate Center and Cooperative Extension, making essential climate science real for the people of Utah.